Let's do this Laplace transform. The second derivative of y minus y equals negative t. Now, if I'm going to do Laplace transforms, I need to have initial conditions. And because this is a second order differential equation, I'll need two initial conditions. So we'll have y0 equaling 0 and y prime of 0 equaling 1. Now let's turn to our Laplace table to find these transforms. First thing we're going to use from our Laplace chart is the Laplace transform of the second derivative of a function. In this case, I have the function being g of t. In our example, we're using y. When we're dealing with the time domain, we generally use lowercase letters, and when we talk about the s domain, the Laplace transform, we use capital letters. So if I have y double prime, I'm going to rewrite this as so. The next thing we need to do is the Laplace transform of y. Well, that is simply y of s. This is something that students often trip up on and aren't sure how to rewrite y of t as a Laplace transform. But remember, the Laplace transform of y of t is simply ys. Also from our Laplace transform table, the Laplace transform of t is simply 1 over s squared. So at this point, it's all just algebra. And that's what makes the Laplace transform a powerful tool. It takes calculus and changes it to basically algebraic manipulation. The first thing we'll do is plug in our values for y0, which is 0, and y prime 0, which is 1. I move the constant to the right-hand side of the equation, and now what I'm going to do on the left-hand side is factor out my ys. While I do that, I'm combining the right-hand side fractions into a single fraction, and after dividing both sides by s squared minus 1, I see this whole thing simplifies to simply 1 over s squared. That Laplace transform will be difficult to look up because I already have it. That is, the inverse Laplace transform of 1 over s squared is simply t. So the solution to this second order differential equation is simply that y of t is equal to t. We could go ahead and check this by plugging in the solution into our original problem. Let's go ahead and do that. In order to do this, I'll need to take the first and the second derivatives of y, and when I do that, I find that letting yt equal t is in fact a solution to this differential equation.